So the time it would take to scan everything with traditional methods, right? They probably measure that in years or decades. Right? Imagine if you were the guy who was responsible for scanning everything at a Fortune 100 company. Anybody here responsible for that? Well, you're probably lucky because you'd probably hate your job. Because you'd be doing nothing but scanning applications all day long, all the time, 24/7, and you'd be running some tool that you're just mindlessly having to bang on. It would be a never-ending task. It would be a complicated task. It would be a painful task. Right? So, remember I said I was going to take you on a little journey. Let's think about how we got here again. You know, what exactly is a web application in itself? Most of the time we think about it as just a web server, something that's got some pages on it, right? Well, those days are pretty much gone. We know that. We know we've got, you know, ASP or .NET or Java or something running behind the scenes. We've got a database in there. We know we've got some other stuff. We also have a whole bunch of stuff going on in the client as well, right? We've got Flash, we've got Ajax, we've got JavaScript. It's all mixed together. Maybe it's HTML5. Maybe it's the next thing. We've got this cool thing called the cloud, right? Tying into every little bit and piece here. Maybe I've got some web services running out there that my website goes out and talks to. Maybe it talks to my back end. Maybe it's glued all these things together. So what part of that is your web application? It's actually the whole thing. So if I'm going to think about testing my web application, it's not just testing that one little server sitting on the left-hand side there. It's about testing all of those pieces. So think about the complexity of doing just that process, right? Even if I'm running a tool day in and day out and I'm running that scan, how am I going to go and test this entire system, right? And the other scary thing is that entire picture right there, that's your new perimeter. Right? If you think your network perimeter sitting behind your firewall and everything is locked down tight, port 80 and 443 are wide open, and that is actually your application perimeter. Your applications are your new network perimeter. And remember, you don't even really know how many of these things you have, right? It's way more scary than, remember when everybody's talked about perimeter going away because of VPN clients and VPN endpoints? This is way more dangerous than that because applications are everywhere. Marketing cannot be stopped, right? They will be creating websites today. They've launched 500 of them while I was sitting here talking, right? And that's great. That's their job. We want to enable them to do that, but how are we as security professionals going to keep up with that, right? So I look at this and I really think this is, you know, if I look at just the Fortune 100, this is really a dynamic analysis failure, right? Automated dynamic analysis tools, they've been out there for 10 years, yet if we think about every Fortune 100 company to suffer a website breach, they all have been using dynamic scanning tools, right? I know at least, just from the ones that I can kind of calculate and know for certain, about 82% of them exactly use a dynamic scanning tool. Probably 100% of them do. But they're all getting hit. Over the last 5 years, every single one that suffered a breach has been running a tool. But the problem is, most of them are not scanning all the web applications they have. Most of them aren't even scanning the ones that are getting hit because they can't keep up with this problem, right? They've got hundreds and hundreds of apps. The apps are exceptionally complicated. They can't scan them properly. They just can't keep up, right? So I see this as kind of a failure in general of dynamic analysis technology over the past decade in terms of the technology we developed. And I stand up here fully responsible, having worked with some of my colleagues to design these things, and we probably started thinking, we're well-intentioned, but unfortunately we might have had the wrong approach. So why are the Fortune 100 really not scanning 100%? Well, so I sat down with about 20 of these folks that I could pull into a conversation, and I asked them, kind of this simple question, and surprisingly, I actually got 1 out of 4 different very simple answers. And sometimes it was multiple answers, but basically, in a nutshell, number one was they just can't keep up. They can't keep up with all of those applications. They can't keep up with marketing. They can't keep up with the business. The web is what's driving their revenue stream, and nobody's going to stand in front of that. So, can't keep up with the applications. It's too expensive to go and scan all these applications. There's no permission in the organization. They don't have the authority to go and scan these applications. And overall, they see a lot of really bad results when they go and sit down, because scanning these applications is tough. It's a complicated process. It's It's way too complicated. There's a lot of noise in the reports. Every time they run a report, they kill a tree. Right? Has anybody killed a tree with an audit report? Have you guys killed a tree with an audit report recently? Don't do that, please. Think about the children, okay? Think about the future. Come on, work with me here, you guys. We're in a tent, okay? All right, thank you. God, wait. I'm freezing back here, right? Warm me up. All right, so bottom line, right? Today's security professionals, they have to pick their battles, right? I would like to say that we need to get out of that mode, actually, because every security professional I talk to, they say the same thing. I'm triaging. I'm picking my battles. I'm picking the things that I have to focus on. I think that's a little unfortunate. So we're triaging, right? We're picking our battles, but are we really ultimately losing the war, right? So I think we forget that triage means I'm selecting the most important things from this large number of things that actually all require my attention. But ultimately, I can't keep up with that, right? Because I can't keep up, because I'm unhappy with the results, because I lack the authority, I don't have any money, I end up triaging what I'm going to end up scanning. So I only scan 1% of my applications, and at the end of the day, even though I have an application security program, like the rest of the Fortune 100, I'm still getting hacked. Well, triage doesn't equal an application security program, right? If your application security program is built on triage, that's probably a problem. So what if we simplify this whole process instead and focus more on an understanding of our assets, right? Understanding of the risk level, understanding of everything that I've got. Because as a security professional, it's probably best if I focus on what is my perimeter? What is my application perimeter? What is this wall or lack of wall? What is this world that I have between me and the folks that are coming to my business and spending money and coming to me for whatever services my company sells, right? So if I could do that instead of trying to just focus on that 1%, would that be worth it? So with that in mind, I want to introduce kind of a thought here. And believe me, I am going to talk about building the zombie horde at some point, okay? This is all the lead up. It's good stuff. So how many people have heard of broken window theory as a kind of a social thing? And this isn't, I actually had lunch with somebody and they said, is that related to broken window failure? And there's apparently a whole other theory that has something to do, nothing to do with inner city crime or anything like that. So broken window theory is, so it's not that. This is all about inner city crime. So broken window theory is in 1982, right? This whole notion of social decay related to very minor things causing larger crimes, right? So I have graffiti, I've got trash on the street, I've got some broken windows, and that tells me as a member of society that nobody cares. So it'd probably be okay if I went out and stole something. It'd probably be okay if I held somebody up for their money. It'd probably be okay if I killed somebody. And we saw this happening in the 80s, particularly in New York and other cities where crime was kind of spiraling out of control. And so we started to address the little things, and it had a profound impact on the big things. So what I'm talking about here is, again, trying to point out, we've been focusing on the big things, the 1%, the triage, and we're not focusing on everything. We're not focusing on the trash on the street, the broken windows. And I think that has a lot to do with why our security programs are failing. So I propose that, and honestly, I don't have enough data to support this. I'm still spending a lot of time trying to figure out if this is true. And if you guys help me over maybe the next 6 to 12 months, maybe my next talk will be on this exclusively. But what I think is, even finding the low-hanging fruits, looking for those broken windows, right? Looking for everything, scanning everything, you're going to have a much better outcome, right? For example, how many people are pen testers? How many people tested applications for a living for the hell of it or because it's cool? Okay, 3 people. I'm totally shocked. I expected everybody to raise their hand. So
the rest of us are wannabes.
Oh, okay. Well, I'm a wannabe too, so that's okay. Again, the right side. You guys suck, okay? All right. Keep it up. As a pen tester, how many times have you gone to a website and you go, oh man, this is going to be juicy? You haven't even actually done anything. You just loaded it up in a browser and you go, oh yeah, totally owned, right? You see the site and you're like, oh yeah, right. So the trash on the street, it's the broken windows, it's the graffiti, right? You just these little things are the indicators to a bigger problem, right? So if I can focus on those, because honestly, those things are actually pretty easy to find, pretty easy to trip over. If I could just focus on those and really send a message that I'm out there to find and fix those things, that might send a message to the whole ecosystem of software development and application development that I'm serious about application security. So that could be an application broken window theory in action, right? And I think, honestly, this is why a lot of our programs have failed, because we focused on just the important things, and the message doesn't get out that we're serious about application security for all of our applications, for our entire application perimeter. Question?
So this side doesn't suck, right? I'll ask the question. So part of the application broken theory window is to engage the community to actually maintain their premises and fix the things. But application owners and application developers don't go around fixing these vulnerabilities.
Well, they don't, because I don't think a lot of people hold them accountable or even let them know that they care, right?
In fact, what may look good to them may actually be less secure. So
That's true. And I'll tell you, how many people have studied computer science in school? Does anybody remember taking a computer science security course? Really? I'm impressed. I think you guys are lying, but that is awesome.
UC Davis, PhD.
Okay, undergrad.
Undergrad.
Wow, I want to send my kids there. Okay, where did you go?
Cornell, but it was the 70s.
It was the 70s. They cared about wow, that is impressive.
CS 101, they were teaching us always check your input.
See, the truth of the matter is, like, you know, in the good old days, everything was better, right? Okay. All right. So, perfect example there. I used to have to hike to school 10 feet. Anyways. So, guys, this side is the first to ask the question, so you guys are a little on the edge here. It was a great question, right? But I think people don't really let people know that they care, right? Because they're only looking at that 1%. They're like, oh, it's only this one app that anybody cares about. We'll just crank out the other one. All right. So what if we could scan everything? Let's get to building the zombie horde, right? So what if we could scan everything, right? That's really what I was getting at. If we could build something that could help create an ecosystem where we create this notion that the trash on the street, the graffiti, everything is not acceptable. Well, what would I need in order to create that reality? And I would need something that would enable me to scan everything and not go insane doing it, right? And that's one of the reasons why we came to this kind of conclusion. How am I going to build a system that could theoretically scan the entire internet if I wanted to? And we decided to call it the zombie horde, because we were watching a lot of zombie movies at the time. Don't press that button. Okay, press that one. Okay, so what are some of the technology challenges, right? So now we have the kind of the theory and the thought behind that, but what are the technology challenges if I actually decide, right, this is how I'm going to solve this problem, what should I do about it, right? So besides the obvious big technology challenge, which is how do I go and run hundreds of scanners and create the zombie horde, I'll get to that in a second. There's actually some really big problems lurking behind it that you should think about first. The first is a lot of scanners have false positive problem, right? False positives at a massive scale are ridiculously annoying. Think about what you're dealing with on just a scan-by-scan basis. If I have 1,000 scans running and they're generating 1,000 false positives each, I might as well just shoot myself in the head, right? So any manual work is required. You have to measure that manual work in the seconds, or maybe you have to measure that really in the microseconds, because if you're not measuring it to that level, it will not scale. Automation is a requirement if I'm going to do this. So think about that. If you go, well, it just takes me 15 minutes to configure this thing. If I have to do that 3,000 times, that's a half a year's worth of work before I've actually started doing anything, right? So I have to think about everything in terms of seconds or microseconds. And it's not enough to just go and build this and then try to solve those technology challenges. I also have to figure out, how am I going to keep this engine filled with targets to scan? Because as it turns out, nobody knows how many web applications they have. Now, companies tend to say, oh, I've got a couple things over there and a couple things here, or maybe I've got 100, or here's a list. But when you really dig deeper, you end up finding there's generally 2 to 3 times as much stuff as they thought was out there. So it's not enough just to be able to scan the sites. You actually have to be able to go and find them in the first place and make them valid targets to scan. Well, of course, there's also people and culture challenges, right? Technology is easy. People are difficult, right? So business has a few demands, kind of illogical demands, but well-intentioned, right? They want production-safe testing. Have you ever heard that? This is going to screw up production while you're doing that, is it? Right? By the way, plugging something into the internet could really screw up production, right? So think about that, right? In addition to trying to at least be kind in terms of how much traffic you generate to the site, which is something you can control, there's really no such thing as truly production safe. But at the same time, if you plugged it in the internet, you're probably getting pen tested every 30 seconds anyways for free. You just aren't getting the report, right? Somebody else has got the report. The other piece is we have these ideas of scans and maintenance windows, and can you do that in off hours because I'm worried about my production site, right? You should put that notice on your site so that when the hacker comes to your application, they go, oh, it's the maintenance window is this weekend. What was I thinking, right? So they're not worrying about that either, right? Again, you're getting that free pen test every 30 seconds. And then we've got this expectation, this unnatural expectation that we're going to find everything when we do scanning. This is why we got stuck in this 1% mindset in the first place, which is that you're not going to find everything. And just because you're not going to find everything, does that mean it's not worthwhile to go and scan everything? Absolutely not, right? But you have to set this expectation right from the start when you start a program like this. You're looking for the things that are most important. You're looking for the broken windows. You're looking for the trash on the street. You're trying to make it clear that application security is important and that no application is going to be left behind. Oh, God, I can't believe I said that. All right. So, forgive me. All right. So, what are our rules for engagement if we're going to do this, right? So we know we have to absolutely maximize our automation. No special configurations, no training, no people. Look for only things that we can automate, right? We don't want to be buried under thousands of false positives. We want to be internet-facing only because I'm not going to deploy a massively scalable cloud-like environment inside your IT shop, set that up, and then break that down in 2 seconds. I don't want any complications of these scans. Remember, I don't want to be spending 15 minutes per site configuring it. So it's going to be no authentication, no complications. I'm only going to look in the places that everybody can reach. That's not a problem. And then those hackers don't have scan windows, so I don't want a scan window either, right? We have to be thinking about scanning as a continuous process. Yeah.
Yeah, but they also want to fly under the radar, and they don't have your site DOS, whereas your tool has a potential.
So, strangely enough, the denial of service thing is the one thing that is actually easier, is the easiest of all the things to actually control and make sure you don't do, because you can throttle yourself. There's some other areas where it's actually a little bit more complicated, which comes to injecting attacks into the site and having an impact there. But there's some smart things you can do there. But at the end of the day, there's no such thing as production safe. But there's also no such thing as running an application on the internet that's safe, right?
I'm just saying, you can't just blindly say, they don't have scan.
Right.
They're trying to fly
So,
the radar, they're trying not to be noticed. So your tool will potentially be noticed. Have a noticeable impact, even if it's like
maybe. But you're right. You're right. We're not trying necessarily to be secretive, but actually there are things you can do to try to run under the radar. And I have a statistic from my case study, which I'll share with you, about how many people actually noticed. Sorry, it's a number as to how many people actually noticed us. So, question.
So you want to scan it in the daytime?
I want to scan it whenever I feel like it. Whenever.
If you break it, somebody's around to fix it?
It'd probably be better to do it at the time when people are around anyways, right? But those are the rules of engagement. So this isn't for everyone, right? Somebody might go, I can't do this, right? So if you really want to do this, this is where you've got to start. You've got to get your business leader, your CEO, whoever is responsible for all this thing to sign off on this. And I've seen it happen for Fortune 5 companies sign off on it and say, just scan it. Do it. So I know it can be done. I know it because we did it, but maybe it's not for everyone. But the thing is, I think the education we really have to share with people is you plugged it into the internet. It's getting that free pen test every 30 seconds. So is that still worthwhile? Hell yeah, because it's fun, but also because we can deliver two critically missing things, right? One, what is my application perimeter? You can start there. That's an amazing thing in itself. And two, now I have a baseline of all my applications. Never had that before. And it's with that baseline that I actually have a better chance of properly prioritizing the actions that I take. Instead of just blindly picking the 1%, I can actually pick maybe the 1% that makes the most sense to go after, or the ones that look the most worse off, or maybe the ones that I didn't even know about, right? I've run discoveries where the CISO of the company has found web servers sitting under people's desks. They didn't even know they were there. And they were driving revenue-generating business. Nobody had ever knew that they were created, right? Walked over that moment and unplugged it because it's a completely unknown entity, right? Now, I'd like to see that happen every single time, get unplugged, but sometimes you have to ask somebody for permission. But being able to scan everything and knowing what you've got, that's really the beginning. So if I'm going to do this, this is really something that could not have even been considered before the advent of an elastic on-demand computing solution. Power. Electricity in the form of computing power that's on demand. This is what cloud computing is to me, right? And really, ultimately, when you think about cloud computing, I know it's a buzzword, everyone goes, oh, cloud computing, to the cloud. It's actually pretty amazing when you think about it from a programmer. If you can allocate computing power the same way you might allocate memory, that is a game-changing event. That is really what cloud computing is about. And it was not possible to even think about building a solution like this or doing big problems like this without something like that. It's also awesome that you only need to pay for what you use. And that means it's not going to cost me $5 billion to do this. Or you. So here's some of the solutions that I looked at. I looked at Amazon's AWS. I looked at Rackspace's cloud. I looked at GoGrid. And I really had 5 criteria that I was kind of comparing everything by: cost, APIs, flexibility, global reach. Did they care about security? It was important to me. And it probably comes as no surprise if anybody's... How many people have ever used AWS or Amazon's Web Services? Oh, awesome. Isn't it? It's pretty good. How many people use Rackspace? It's also pretty cool, right? I like both of the solutions. I think they're great. We chose Amazon. Later, we went and deployed it on Rackspace as well, so we could have options. I think they're both great. But ultimately, at the time, what could cost me $1,000 on Amazon, not so much, maybe a little bit more on Rackspace, but ridiculously more on GoGrid. I don't know why, but that's what we came out. And probably a lot of it had to do with how we were using Amazon Spot instances, well, I'll talk about in a second. But really, it was just this massive community support as we were building this thing. Yeah, right?
Jay, pushback with Amazon care what you're actually doing, that you're hacking websites from there.
Yeah, so that's on the next slide, actually.
Okay, good.
That was when we started the nuclear war. So when you're building something, it's really good to know that there's a community out there trying to build stuff so that when you have a question, you can ask people, hey, does this API work? And they go, oh, there's a bug. I'll fix that for you. It's super important. So tons of APIs, tons of SDKs for AWS, and that was one of the tipping points. And then they've got an enormous amount of infrastructure that you can build on top of it. It's not just EC2, but a whole bunch of other things. We didn't necessarily use all those things, but pretty useful. So we went with Amazon. These are the services I ultimately ended up using. Obviously EC2. EBS, which is for storage. S3, also storage. Slightly different model. I won't go into the details there. Some other little bits and pieces. Actually, when I started, IAM didn't even exist. That was really annoying, having to give everybody the same username and password. They fixed that, thank God. But they have all kinds of stuff that you could play with. Maybe I'll create a talk just about AWS. But those are the services we used. So what were the other considerations, right? So actually, we didn't start war. We actually called up Amazon before we started scanning anything and said, hey, this is what we're going to do. Is that a really bad idea? Will you even let us do that? And then we told them how much computing time we're probably going to use, and they said, that sounds like an awesome idea. Right? They're in this business just like everybody else, and that they really like the amount of computing time we use. So other things to think about, though, is it is difficult to manage your costs when you think about how you're going to bill that back to your customer, or how you're going to think about how much you're spending per system. There's no really good mechanism in AWS to track this right now, so we had to deal with that. They say they're working on some improvements. I haven't seen it yet, but I'm convinced that they're going to do something better about that. And then you really have to think about building a survivable system. You can't just assume, oh, Amazon's going to take care of my uptime for me. Has anybody ever heard of Amazon going down? It's happened a few times, right? That's okay, as long as you keep that in your head. And they give you all the tools to design around it. You just have to realize that just because you went to the cloud doesn't mean all your problems went away. It's actually, they're still there, but now you have a bigger toolbox in which to address them, right? So we got approval, and they were very kind to let us do what we were going to do, but it's totally a violation of the terms of service if you just go and do it. And by the way, to begin with, you're only given 20 instances. So if you wanted to go fire up 1,000 instances, you're going to have to talk to somebody, which was a surprise to me. I thought I could just put my credit card number in and purchase all the computing power in the world without talking to a human, but that was okay. So this is a slide that I chose this color to wake everybody up at this point. So there were some security considerations. So we thought about, maybe our security problems won't go away because Amazon will take care of it for us. Wrong, right? We have to take care of that as well. So here's some of the things that we did. So we made sure that our data is encrypted. It was really important to us. So we used encrypting file systems. We used SSL and SSH everywhere. We just never sent anything unencrypted. We never stored anything unencrypted. And oh, by the way, don't store your keys in the cloud. That means it's not encrypted. So you have to think about how you do that. But when you provision your boxes, you can bring them up. You can push the stuff in. There's ways to get around this. I actually wrote a blog post on my blog, if you find it, talking about how to go about encrypting EC2 instances, file systems on EC2 instances. And you need to make sure you've got the right access controls in place. I hate passwords, so we use keys for everything. We made sure that everybody's got individual accounts, all the APIs are controlled. And then you really want to think about where your physical systems are, because you might want to distribute the load, you might want to design for failure. We primarily use US East 1, but we could deploy this really anywhere the way we've constructed it and spread it out. And the great thing about that is if you decide that you have a client that's in Sao Paulo or Tokyo or Singapore someplace, you could easily be popping out and scanning from that location without much work on your part. In terms of uptime and availability, it's been pretty good, but again, you need to design for that. So we considered that and how we deployed. And then Cloud Security Alliance, if anybody went to that earlier today, the CSA had a thing at RSA. I didn't go. I was finishing this presentation. That was a joke. So they've got a great place to start, but ultimately, security is your responsibility. So if you're going to go and use something like Amazon or Rackspace, you can't just say, oh, I've outsourced it to those guys. They're going to figure it out. I read somewhere that it's PCI compliant. Awesome. It doesn't do anything for you. It's your responsibility. You have to make sure you get all these things right. You're managing a bunch of systems. They happen to be running in the cloud. They're still your boxes to make sure that you've locked down, right? So this is where we really spent a lot of time, because the first time we did this, we had a bunch of epic failures and then realized that we were not designing for failure and it was really our own fault. So it doesn't necessarily mean that AWS is constantly going down. It's pretty stable, actually, but occasionally things do happen. So you want to expect systems to fail. As you're building a system out, you want to make sure that if things are terminated suddenly, particularly if you use spot instances. How many know what spot instances are? I'll talk about that in a second. So real quick, spot instances are like you buy computing power at the market rate, and then when the price of that computing power goes above what you're willing to pay, your instance just goes poof. Your machine goes away, which is fine because you're paying a really cheap rate. But if you haven't designed to handle that kind of poof, then everything you've got goes poof, right? So what we did was ultimately, like that. So what we did ultimately was anticipate that there's going to be random latency at every point in the system. So as part of testing that, we would randomly kill stuff. We'd randomly slow things down. We'd randomly just make things awful and see how our system handled that. Netflix has got a really interesting blog post about this. I think they created a process called Chaos Monkey where they go out and randomly kill stuff. It's pretty amazing. And they run this in production, which is pretty cool. So we thought pretty hard about designing for failure when we built this thing. And then we also thought about something that was also really important, which is making money. And we thought about designing for cost. So that means you have to really get religious about thinking about the cost of everything, down to the penny. Right? Because when you're only running one machine and it costs you 5 cents extra, you might not be thinking about it. When you're running 1,000 machines, it can really add up really, really fast. So we thought about everything in terms of computing hours, bytes transferred, storage, keeping IP addresses around longer than we needed to, everything that you can possibly do. Amazon puts a cost on everything, and you really need to be religious about that. And then you really need to make sure that you're only using what you need. But there's some things you can do that you can optimize, and these are just some of the tricks that we kind of thought about. Right? For example, an instance is charged by the hour. So if you've got a machine and it only ran for 5 minutes, you might as well leave it around up until the 59th minute before you kill it, in case some other work shows up. You can save some money that way, actually. When you're using a lot of machines, that actually happens more often than you would expect. And then sometimes it's just cheaper to lose work and start over than building all this complicated infrastructure to handle that. Just some things that are kind of counterintuitive when you start thinking at scale. So here's what we came up with. Ultimately, this is kind of what, dare I use the term hybrid cloud, which we've got a private cloud that Amazon's constructed, which is really our solution for dynamic scanning, and we interfaced parts of that with the systems that we're running in Amazon, particularly for starting up things or kickstarting the whole system, and also for pulling the data back, because we didn't want to leave the data out there any longer than we really had to. Each scanning system uses a dynamic scanning engine that we created as well. And that's kind of the part that I don't go into too much detail here, but it's really important if you're going to build a massive zombie scanning solution that you have a scanning engine that you can deploy in the cloud as well. Just a small little detail. So we've been working on that actually for a couple of years until we unveiled it last year. And then we built what we created around July last year is the central controller that monitors everything. That's really the brains behind this whole zombie horde. There's got to be at least one brain that all the scanners are chasing after. And we built the whole thing in Python and Java. We use the Boto API, which is really friendly. Python makes this so convenient. And then our scanner is written in Java. So the dynamic scanner, this is all I'll talk about here, but it was designed really for this kind of deployment. We were expecting at some point to deploy this in our own kind of cloud environment. And that was under development for a long time before this project started. But when this opportunity came around, thankfully it really lent itself to it. This is the kind of the linchpin piece that you've got to have. And it's not easy building a dynamic scanner. That could be an entirely different talk. So just some key design considerations that lent itself to automation, that lent itself to this kind of deployment. We didn't build it for pen testers like every other scanner ever built. We built this for automation. We wanted to make sure that it was absolutely as simple as possible. It made all the unimportant decisions for you. That it only looked for the critical flaws because we didn't want to kill forests. We didn't want to deal with the false positives of doing that. And ultimately, this thing just produces these little atomic facts about the application as it's running through that, and we do a lot of post-processing to figure out what we're going to do with those facts, right? One of those includes determining if they're truly facts, right? And then we made it as safe as we could. So that means trying not to denial a service the system, trying to be as low impact as possible. For example, there's just a couple ways. I'll just mention one. For example, how many people know about SQL injection? Everybody, awesome. Okay, so there's a lot of ways to test for SQL injection. Everybody's gone to a website and said, I've got a single tick in my name, right? Oops. SQL injection, right? So if you do a single tick, or 1 equals 1 kind of style thing, you know what you've actually done? You've modified the logic of that query. And if that query happens to be behind that system that you just modified, happens to drop tables or delete records or anything like that, that could be a non-production safe activity, right? So one of the things that we did when we thought about all the attacks that we inject is to think about how that impacts the production system that we might be running, and actually created injection strings that do not change the logic of the query. And that took about a year's worth of research to cover all the database platforms and all the permutations you could possibly imagine. But those are the kinds of things you have to think about. So it's not just denial of service, but also thinking about how you're going to inject things into the system. So in terms of the AWS instances, so for the scanners, we used specifically M1 large instances. These are about 7.5 gig RAM boxes. Didn't really need that much memory, but it was just kind of how the system broke out. They're about default 9 gigs hard drive. We bumped that up to 30, but you also have something called ephemeral storage, which you get with each instance. And if you have an M1 large, you get two about 400. I couldn't remember exactly. It was about 400 gigs ephemeral storage. This is just storage that's there. If your instance disappears or turns off, it's gone, so don't put anything important in there. But if you need like a lot of temp storage or anything like that while you're doing your work, it's a great place to put it. We actually ended up merging those together as a RAID 0 array and encrypted the whole thing. And we saw a definite improvement in our performance in doing just that within Amazon. There's a whole bunch of science behind how Amazon manages EBS volumes and ephemeral storage. EBS volumes are off on some SAN somewhere. You have to go over a gigabit network, whereas ephemeral storage is a little bit more local, I think. And it runs just so much faster. So if you're going to have any kind of working space, that's the place to put it. And we used Amazon Spot instances wherever possible to save cost. The controller was another large image. We had a big spot to put all our processing of our data, and that was on demand, obviously. We didn't want to have that shut down on us, but it's this controller could be split out between multiple regions with multiple systems kind of talking together. And ultimately, though, our network and storage costs were negligible compared to the computing CPU times that we needed. So this is where I talk a little bit about spot instances, because we used a lot of spot instances, and for a while it was just like the most cool thing in the world. They never went down, and we weren't even at the time thinking about if they were to go down when we first started playing with them, which was dumb. Don't do that. And but they're really cheap, so why wouldn't you use them? Well, occasionally you get these weird market fluctuations. So even though you're paying maybe 11 cents and the market going rate for that image is 34 cents, but suddenly somebody decides they need a lot of computing power from Amazon. And so you get these spikes. So it can go from 11 cents an hour to $20 an hour. The other day I saw it go up to $99 an hour, right? And if you're using spot instances and you're doing a lot of processing, you have 100 instances or 1,000 instances, they all go away if you haven't agreed that you're going to pay $99 for your instance. It's probably a bad idea to do that, because that would be very expensive. So you need to think about how you're going to store data, backing up, being able to pause and resume and start over and things like that if you're running your scanner. And don't ever set that price higher than you're willing to pay, because sooner or later you will end up paying it. Question?
When the spot price jumps up, they terminate all instances across all customers that are that price. If like a single person asks for one machine, I only pay $99 an hour because I want to deny the service my competitor who spot instance, I'll pay $100 everything shuts down.
Right. So the question is, if one person asks for one instance and they're willing to pay $99 bucks, does it move the whole market? And the answer is no, it doesn't. What moves the market is a lack of capacity, right? So when we started ramping up and getting to the point where we had 1,000 instances to play with, we actually started to see at certain times of the day we could move the market, and figured out, and that created some really interesting effects when you try to launch 1,000 at the same time, and half of them come up, and then the other half crash because you just moved the market, and then the other half come back up, and then it crashes, and it's bad. So you have to kind of think about how you go about consuming all that computing power. Yeah, it's kind of an interesting. I'm really curious to see how it progresses. But if you look at the spot instance price over time, it's kind of crazy. Something to think about as you're building this. So these are all our top secret details that I wasn't going to tell you. They've all been redacted, right? I'm not allowed to tell you about the 5th developer on the project. He's not here anymore. I'm kidding, I think. But in this day and age, we have to be careful. We did build this solution to totally dominate the market, of course, right? So here's some other pitfalls to think about. when you're designing a system like that, bugs can have really frightening consequences, particularly if you're not really paying attention. When you have bugs that are launching, remember that programmatic access to computing power, and you have a bug in your code, you can accidentally launch hundreds or maybe 500 instances with a little bug, and if you're not really paying attention, or maybe you go for a cup of coffee, you can come back and go, that bug just cost me $645.48. Not that that ever happened to me, by the way. The expense report is in the mail. But it's totally true, and it's really tempting to just kind of test in production. There's no test like production as you're playing with this stuff. Don't do that, because it could be really expensive, literally really expensive. And we were lucky, but I've heard of other horror stories of people starting up machines and then going away and forgetting about it and letting it run for months. And they thought they had 10, and there was like running 500, and they're in trouble, right? So you can spend money really, really fast. So you need to think about that. So let's talk a little bit about a case study. That's a big truck. So when we first started, working on this project, the idea of scanning this many applications, doing this kind of thing, had never been attempted before. Nobody had really thought about scanning this. Let me see how much time I got. Right at the 15-minute mark. That's perfect. So people had been scanning applications by throwing lots of bodies at the problem. And we had a customer come to us and they said, look, we have a real problem. We don't know how many applications we have. We don't know what's wrong with them. We know we're under attack. Please find out before the hackers find out, because we know they're pen testing us 24/7. So we said, sure, let's see what we can do for you. And thankfully, the right parts had kind of come together. We had been working on this, and so we kind of moved quickly to design the system a little bit earlier than we thought. And we found out that actually, this was something that was going to be really doable. And the interesting thing is that they started with by giving us just an enormous list of 30,000, basically a dump out of their DNS. Said, well, here's everything we think we have. We're not really quite sure. And so we had 30,000 domains that came out of that DNS, and results of like a bunch of random Nmap scans. And they said, we need you to scan all of this. And that came out to about 30,000 sites, 30,000 systems. We thought, wow, that's going to be fun, scanning 30,000 systems. How fast can we do that? So as part of that process, we went through a discovery, and we found that actually only about 5,000 of those were unique sites. They had registered a lot of typo domains. They registered a lot of dead domains. They registered a lot of stuff that just somebody had registered years ago. We're still paying the bill and long had forgotten about it. And that turns out to be pretty common at Fortune 100 companies, where they've got a bazillion domains and they don't even know what they've got. So we went through the discovery. We came out to about 5,000 sites, and then we had a couple filters that we put in place, and that came down to about 3,000, specifically 2,994 sites. And so we set out to scan those sites. So zombies don't sleep. Neither does the zombie horde. So when we started the scanning, we kind of ramped up slow, because we had learned our lesson about launching thousands of instances into moving the spot market. And we started to ramp that up. We didn't have any scanning window. We had full board permission to go. That rule of engagement is really important. We would not have been able to accomplish this without that. And we started slow and then really rapidly grew. And then really by day 5, we had scanned pretty much everything. Things were starting to settle down. But the interesting thing is there was 0 notification that was sent out to any of the site owners. It was so important a task, we just needed to do it. But it also gave us the opportunity to really test how we were going about this kind of production safe mode. Only 2 of those people actually even noticed we were there. And that's probably more a comment on the sorry state of application IDS than anything. And the only reason those 2 people actually noticed is because we hit a form, and some poor guy had like 10,000 emails in his inbox in the morning. And by the way, if you're ever testing a site and somebody goes, stop that, you're sending me emails every time you test that site, you should say, stop that, you have a really bad form that needs capture or something. I mean, my God, what are you thinking, right? Anybody can go to that web form. That's a vulnerability. That's a problem. So we worked with them on that. And at the end of this whole process, we consumed about 18,000 hours of computing time. It's about 2 years of computing time in about a week. Took us about 4.5 hours for each site to be scanned. In this one, we only used 500 scanners. Now we use about 1,000. And out of that, we found over 1,500 validated flaws. And I say validated is because we wanted to actually know how well this thing was working. So we sat down and went through everything that came out of the system. And we built a whole kind of process to manage that. And actually, as it turns out, thankfully, we had a pretty low FP rate because we were only focused on the things that are most important. Yeah. So each one of those sites is unique, and each one of those vulnerabilities is unique. That's right. Yeah, those are unique flaws. So think about that. They had 3,000 sites that had never been scanned. They never sat down to do it. They'd only been focusing on the top 1%. They were getting hacked like everybody else. And we'd come along and scanned everything using a very broad, very fast, very go for broke, scan everything kind of approach, and found 1,500 things that they didn't know about. It's pretty amazing. So the process after that was actually to, instead of spending all of our time scanning, which is where most application security programs get stuck, they spend all their time scanning. I talked to one client, he said, by the end of 2012, we'll have scanned all of our applications. That's a year from now, right? I said, wow, that is awesome. You got a ton of work going on, but isn't that kind of unfortunate? And I said, well, what do you mean? We're going to have everything scanned. How awesome is that? And I'm like, your entire application security program is about scanning, not about remediation, not about building better policies, not about helping people understand, educating your developers to write better code. It's all about scanning. So all that means is by the end of 2012, you will now know that you're screwed, and you now have a lot of work to do, right? So the amazing thing is if you can actually stop thinking of scanning that way and you start thinking about scanning very broadly and very quickly like this, is that your application security program moves away from just thinking about scanning and now onto fixing things. The whole project itself was completed under 3 months. That included going back and rescanning applications after they fixed vulnerabilities, after they dealt with things, turning off a lot of those applications because they didn't even know what the heck they were doing out there in the first place, and that they should have been taken offline a long time ago. And in a way, I think this kind of fed into the broken window theory a little bit, in the sense that all these sites where this low-hanging fruit was found, right? They target that with deeper, more aggressive scanning later, and that's where they found the majority of their really scary problems. And so over time, I'm really tracking this to see if the overall security, independent of what's actually found, is actually going to increase, because I think that'll be one of the key indicators that this kind of theory is in effect. So, in closing, there is hope. So there's really no reason to not scan everything. The costs aren't too scary. The fact that you can build your own dynamic zombie horde is certainly interesting, or you could just certainly, shameless self-promotion, you could give me a call. I'll be happy to do it for you. But ultimately, this makes delivering the results the focus of your program, not scanning. Because even though I've just been talking for the past hour about scanning, really what I want to do is change the conversation for most companies so that they don't think about scanning, because it just happens that fast. And they focus really on all the things they need to do afterwards. But if you are going to do something like this, make sure that scalability is a religion. Automation is a key. If it takes you 1 minute, 1 minute's too long if you have to do that 10,000 times. Make sure that you optimize for performance, optimize for failures. In other words, expect the failures, and optimize for the cost in terms of both time and money. And and expect the unknown. Just because it's in the cloud doesn't mean that the problems that you have in existing IT are going to go away. So that's it. Thank you for your time. I love both the right and the left side here. You guys are awesome. I appreciate the questions. Any more questions? Yeah?
So, distributed across multiple regions, Asia Pac, US. You're scanning a customer who's worldwide,
Mm-hmm.
has worldwide distribution. You still only have one controller, or do you break it up into different regions?
We break it up because it's more scalable that way, and there's actually some bandwidth costs within Amazon's cloud. So if you put it locally there, your costs are a little bit less. And and there's less latency between the controller and your scanners, so that we break it up that way. But you could do it either way. Yeah.
I was actually going to ask about the bandwidth.
Sure.
It seems like web applications getting into that.
It's very heavy bandwidth. Yeah.
What's if you can say what's your like breakdown of like compute time versus bandwidth?
Compute time accounts for 95% of our cost. I'm actually really convinced. Every day I'm convinced that something must be wrong, or Amazon forgot to bill me or something, because the bandwidth is huge, but I think the price is just that good. But we try to optimize a lot of stuff, and surprisingly, the great thing is a lot of people host their sites on Amazon. When you're scanning a site hosted in Amazon, your bandwidth costs are almost free, right? But yeah, most of it is computing time. After that, it's storage, and then it's bandwidth. Any other questions? Awesome. Thanks, guys. Really appreciate it.